we'll hop into it. So welcome everybody to tonight's class. We're all good here. Looks like we've got 50 or so people. What we're going to do first, thank you very much, Kamal. I'm going to open up the attendance. So I'll set that now so you can show it. You can all access the attendance choice and fill that in. That should come through in a moment. A little bit slow tonight. There you go. Can someone just confirm in the chat box that we've got attendance okay? I'll turn the on the other one so I can see. Looks like we've got the chat boxes all working fine, so that's fabulous. So we're just having a look at the weather while we're waiting for you all to turn up. And I don't really know how much you can all read weather maps, but that's on the Bureau of Meteorology site. And as a builder, you pretty much need to know what's going to happen with the weather down the track so you can plan your jobs and you can get a bit of an idea of what's likely to come, because in Australia, our weather in most cases across southern Australia tends to come from the west towards the east. So you can see there's a low pressure system, which is 1008 in the centre of Australia. Low normally means there possibly can be some rain attached to it, but I don't think there's too much in there. And high normally is fairly dry. So there's an old saying, low for H2O and high for dry. Generally, when you see highs come across, once they settle in, there'll be dry type weather. Low for H2O and high for dry. You all heard that before? Maybe not. You probably need to learn weather maps, because when you start becoming a builder, your job is a lot of times outdoors and you're going to try and plan yourself for in the future. If we look at a map like that, I'd be saying that normally takes a couple of days for what's happening in Perth to get over this side of the country, at least through to here. So everybody around sort of the Griffith, Wagga area, we'd be influenced fairly heavily by what happens in Adelaide and Perth. We generally say what happens in Adelaide happens in Wagga or Griffith a few days later. But you guys on the coast are influenced more by local systems, so that's going to affect you a little bit differently. There's good job, Jared. There was a bit of rain, looked like, here and there, and I can see Nicholas has said drips and drops across rooftops of crops. Awesome. We're going to turn that off now and we'll head into the evening's session. So we are being recorded, and this will be up at the end of the evening. Glenn's helping us out with that. So tonight we're going to hook into a session which involves a tiny little bit of revision, a lot of looking at different footings and the codes and things to get you familiar with it. And there's quite a few activities as we go through which are going to give you a bit of practice at looking at them. And I went through it this morning and during the day, and had a look at it all and set up some things there for you. So hopefully you're all good to go. I'm just going to open up this first item, which is an overview of design procedures. And I'll make that large. And this is a document that was put on some time ago by the guys, and it's pretty much just gives you an overview of what the standards often look like. And with the standards, that what you'll find is that there's somewhere at the beginning of each Australian standard, in this particular case 2870, although this is not a direct quote from 2870, and 4.3.2 is an older standard than what you have access to now, it actually doesn't say that wording. This is an example of what is in the standards. And so it'll talk about some of the different steps involved in designing a building. Now, this is real useful for us because, for example, when we come to designing of structures like the footings, or in our case tonight, the floor framing, we have to know certain things. So we've got to classify the site, look at topography, select what load's going to go on top of it, do documentation, and there's quite a bit involved in it. So we're going to have a look at that tonight. The first thing we're going to start looking at is footings. So just checking to see what the comments are there. Something needed fixing. Looks like we're all good. Hopefully Brett's got that sorted there. That was probably to do with the attendance. So I'm going to show you this next part here. We're going to have a little introduction here to selection of footing systems. And I've set up a little screen grab here that I made up from Australian Standard 2870 of a couple of items from here. And this is basically a screen grab from a part of 2870, just to focus you all in on the one spot, to show you how the procedure for selection of footing systems. This is pretty much what we want to do. And if you think of Mr. and Mrs. Smith's house, when as an engineer or as a building designer, if you're going to do any work involved in the footing systems, what you want to do is actually select the type of footing system that's there. And it talks in here about the selection procedure, and it pretty much says standard deemed to satisfy designs are in accordance with clauses 3.2 to 3.6, which will be down further in the standard. And it says this information those clauses do not apply to these unusual type buildings. So that's unusual, difficult sites, big buildings, slabs that have unusual type joints, a little bit out of the ordinary, large, unusual type construction. So if we're going with anything that's fairly standard and fairly usual, then we're pretty right to use the standard type designs that the standard works with. Remember, with the National Construction Code, we said that we can use what the code gives us so that we don't have to do design things ourselves, or we can go in to use what the code has. We can use the manufacturer's details for things, and we're going to look at a few alternatives tonight, because you don't have to be limited just to the code. We used to have a building inspector with the council, an older guy who did a good job of inspecting around Wagga and was here for years, probably 30 or 40 years, really well known, related really well. And he often used to say to us, you guys can design your own buildings using these standards if you choose to, because you probably do a better job than what some of the plan drafts people or some of the people were doing, who might be over engineering or over designing things. So you're getting enough knowledge now from the Australian standards so that you can have a chat to your designer or engineer and say, well, we don't need to go over the top with something that's just going to cover you way more than what you need. We can stick to something from Australian standards. And if you've referred things to Australian standards, then that gives you good coverage. And you can see that, for example, for stiffened raft designs, this is a typical drawing, and it gives us a whole lot of different scenarios. You probably wouldn't have a house where you've got this type of footing on this side and this type on that side, unless you've got a steep sloped block. But this gives you some of the different scenarios, and it has codes and things on there. And we have to learn to read these quite clearly so that we can actually go onto a table and look and see what D is. And we can look on a table and see, for example, what any other codes and things are in there. There's another D here, which stands for depth. And we can use tables and things like this to be able to design different types of footings. And I've got another specification here for commercial footings that deals with fill and slab edge details. So this is an example of some of the drawings that are presented to us when we go looking in the Australian standards. These will also appear on the engineer's details for the plans for the job that you're building, if the engineer's decided that this is the type of thing that would be suitable for that particular job. So you can see it's quite clear, quite well set out. It'll have, if there's any measurements or things, then it'll have codes there to be able to refer to a table to give you the measurements and that type of thing. So you can see these are some of the main examples in this case for the fill and slab edge options for low side of sloped site, which often occurs with buildings. So there's 3 examples there for you for commercial type footings, how we can just look into the codes and we're able to look them up. So we're coming I promised you today in the message I sent you that you should be able to get 6 completions fairly easily tonight. And we're coming up to the first one. I'm just going to show this guide to residential concrete floors. And we're going to talk now briefly about floor systems. Just have a look here. So thanks, Brett. Alternative edges commonly used in Perth. Perth's real interesting, actually. I'm not sure if anybody's built over in there, but pretty much most of Perth in the main area of what you call Perth before you go outside of it is all sand. And so pretty much what happens there is everything kind of floats. And they actually build a lot of double brick construction there. The main brick company there, I think it's Midland Bricks or something, they basically set up years ago and took the market, and almost every house over there in the new subdivisions is double brick, rendered on the inside, pitched timber, pitched roofs with if they're even if they're a steel roof, they're going to be pitched as well, probably. Very few trusses that were used over there. I went over there a couple of years ago and had a look around, took a heap of photos of building sites and new subdivisions and everything, and pretty much it was amazing how they build so differently over there. Lots and lots of brickies over there, but basically Perth is built on where there's a lot of rock and brick and dirt and stuff around for bricks, and so that makes it easy for them to be able to do that. And there's not a lot of timber there either. They do grow a little bit of forest down south. Some of our great hardwoods come from there, but to get all the pine and things that we get, it's got to all be trucked across, which they do a little bit of, but not as much as you would think. So our first activity to get your first little progress bar, straight into it tonight, is a quick quiz, which I'm going to outline for you. And I just want to quickly say a couple of things first about the resource. So you can see on my screen here, I've opened up the resource and there's a quiz. And what we're going to talk about now here is is floor systems. And I've gone to a book here by the Cement, Concrete and Aggregates of Australia organisation. I just want to quickly show you who they are so that you can understand where they fit and why they're not an actual Australian standard. So you can see these guys are a not-for-profit organisation established a long time ago and committed to serving the Australian construction community. And their main aim is also to promote the use of cement, concrete and aggregates in Australia. And if you look at their book here, this book was released as a publication to cover slab-on-ground floors in detail. It contained only a limited outline of the alternatives available, and they've brought through this particular version, which is promoting for the concrete organisation. Basically, it's a plain, easy to read interpretation of 2870 and some of those other codes. So if you look here at, for example, the references, and I think I can go straight to the references. When you look at the references, we've got the Building Code of Australia, we've got 2870, so that's the one you're going to become real familiar with. We've got 3798, which is guidelines on earthworks for commercial and residential developments. We've got the termite code. We've got the Housing Concrete Handbook, which is a book that they've produced themselves. The books that these guys produce, and there's many organisations like this that do this, they produce it based on the Australian standards usually, or their own research, and they produce it to be able to make the standards and things easier to read. So as a reference, they've used Australian Standard 3600, concrete structures. Then there's another Australian standard coming up down here. We've got 1684, which is residential slabs and footings. We've got 3610, which is formwork for concrete structures. We've got 3610, a supplement. Up here, we've got 4671, which is steel reinforcing materials. I'm going to show you that a little bit later. We've got 1366, rigid cellular plastic sheets for thermal insulation. We've got 1530, which is methods for fire tests. And then there's further reading. So we've just skimmed through a whole heap of standards that are in this book. This is a 47-page book that's been put out by these guys. And this is a good reference for you to be able to actually easily understand some of the things to do with slabs. And so the first thing that I'm going to go through and do with you, and I'll do a couple of these and then you can finish them off. We'll give you 5 minutes or so to finish off some of the questions. And you're going to be skimming through this document here, which you probably don't need to download, but you're welcome to if you want to. And you're going to skim through this document and answer some questions. And this is how you'll learn some of the different things that this booklet outlines to you. So I've just opened up your first opportunity to get a little green box. And I'm going to open it up in a new tab. You can jump on now and start that if you like. I'd recommend that you open up the book on one tab and then open up the quiz. So you can see up the top here, I've got the book there, which is this book, and I've got my quiz here, and I'm going to go back and have another look at it because I see 9 of you have already jumped on. The last one I looked at was question 10, so I'm going to jump onto question 1. I'm not sure if they're all in the same order as you, but this particular question, I'm going to go through a couple of these with you, and then I'll let you work through this book yourself. So a lot of this is going to be about reading the book. Now, on the book, there's 47 pages. If you had time, you could read all 47 pages and you could probably answer, if you've got good memory, you could answer these questions yourself. But I'm going to go through with you and help you with some of these so that you can, if you find that question, you can work through and then type in the chat box. If you find the page number that's got the answer, and we'll work together to be able to complete these and do some good learning on it as we go. So this particular one says, select the most appropriate answers for the table shown below, hint page 9. I'm going to go straight to page 9 because we've already been given a hint. Page number on the actual piece of paper is the one we're looking for. So there's my page 9, and I'll look at the question. Table 4.2, likely surface movement for various site classes from Australian Standard 2870. So this is taken from 2870, but the book has reproduced it themselves so that they could just make it easy to read for people, and there'll be a little bit more explanation around it. So we've got S here, and if I go to site S, you can see it's 0 to that, and that symbol there means less than or equal to 20. I'll just make that big so you can all see that. Hopefully you can see that. This is taken from Australian 2870, standard 2870, but remember it's been put in a little bit more layman's language because 2870 has a table like this, but it's just a little bit harder to read and a little bit more hidden. So when we look at M, we're going from that's greater than 20 to less than or equal to 40. So that's what that symbol means there. And I'm going to have to try and choose that one there. So greater than 20 or less than or equal to 40. And then I'll go to H, and H is greater than 40 to less than or equal to 70. So I'm going greater than 40 to less than or equal to 70. And then the last one is E, and E is more than 70. So with E, I'm going to go more than 70, and I'll lock that one in. I can lock that in or just go to the next question. So any questions about that at all? Hopefully you're all going pretty good with that. So this next one here, refer to figure 4.9. Okay, we're going to find 4.9 on here. I'm just going to use the Control F and go 4.9 and search for 4.9. And there's 2 mentions of it. Here we go. That's taken me straight to it. So to bring up that little search box that you can see up the top there, I've just pushed Control F on the keyboard, which is Control Find. And on almost, I forget for Macs, but on almost any Windows-based computer, anywhere where you are on a computer, if you push Control F, it'll bring up a little search box and we can find that. So here's figure 4.9. Let's jump back to the question. There's what is the minimum crossfall of paving for given site class H and E? Ensure answered in, so we've got to type it like that. We've got to put 2 numbers and then an MM after it to get it correct, because that's the only thing that the answer will accept. And so we're looking at site class H and E. Site class H and E, so we're looking 50 millimetres in there. I'm going to type in here 50 mm, and I'll just check that we wrote that correctly. We have to type it as a 50 mm, so that should give us that one. And we'll bump across to the next one. So heaps of blokes don't even use mesh in their footpaths now. Correct, Sam. Now that, Sam, you've just raised a really good question. I'm going to make a note on my page here because I want to refer to a footpath standard, which I haven't mentioned to you yet, but I'll bring that up after we finish this little quiz and talk about that. Thank you for that, Sam. So here we are on the next one. Are you all keeping up here okay? In the construction industry, what is a board footing? And we've got to drag one of these up to there. Well, some will say I'm cheating here, but in reality, the world these days belongs to the people who can find the answers to things where it's been printed as quick as possible, because there's no shortage of information out there. And I think we've already demonstrated to you that you've got access to all the standards, all the regulations, all the rules. Just need a fast internet connection and a computer with a mouse probably. And so the quick way to be able to find that is just to be able to do searches and things. And I've just searched through that 47-page document and in about 5 seconds found the word board. And that potentially is the answer to a question that somebody might have asked me on the building site. Someone might have said, what's a board footing? The client might have said, what's a board footing? Not that you're going to grab your Google on your phone straight away and search that up, but you know now where to find the information. And I think that the most important thing that we can teach you is where to find information rather than what the actual information is, because these terms and things change. Stuff changes from time to time. While I'm talking, I can't think. Formed by augering the foundation soil. Is there one of those? Yeah. That one there looks like the one. Happy so far? I reckon I've probably shown you all enough for a few minutes. I'm thinking there's 10 there. How about I do 2 more and then I'll leave you, say, 5-10 minutes. I'm not sure if we can pause the recording so that we don't get blank space, but what we might do is let you do some yourselves. I might do the next couple and then you can work on the last 5 yourselves. You chose the wrong one, Adrian. Thank you, Josh. Did I choose the wrong one for that last one? Board footing. No, don't pause what Brett said. Josh, did I get the wrong one? Oh, created by augering. Oh, thanks. Okay, very good. Whoa, I read the first couple of words and missed it. You've got to be careful. Thank you very much for that. Brownie point to Josh, and for helping me out here, James, for helping me out here in the classroom. I don't know whether my video is working, so I don't know whether you can see all the people in the classroom here today. Maybe that's a good thing. Yeah, all types of wall construction can be supported. However, now that's going to be really hard to find in a document that big. You could go to the top here and start looking through, but look, I must admit I did a little bit of a cheat and I grabbed a few of the words and letters from that and put it over here into this little document. And I found that there's only one time when it's mentioned, and it's on page 16. And so there's my wording there. I'm going to read that and see what that says, because it's saying here all types of wall construction can be supported. However, with class H, E and P sites, consideration should be given to articulating the walls. That is, dividing long runs of walls into shorter panels. Now that's real interesting there, because that word is used in the Australian Standard, but it's quite hard to find the definition of it. And there's a quick little definition there that gives you a real plain English version of what articulation means. Okay, so let's just go back to our question. However, with class H, E or P sites, with class H, E or P sites, consideration should be given to articulating. That'll be the next word I'm thinking. Articulating in the walls, that is dividing them up, usually at door or something openings. Usually at door or window openings. Figure 4.11, that looks good. And the rest of the question, joining materials or timber framed infills are often used as the dividers. This method of construction allows each panel of something, allows each panel of masonry to move something or other. I'll come to your chat box question in a second. This allows each panel of masonry to move independently. So the last word there looks like independently. I think I've got that one right. And I'll do question 5 and then I'll set you all loose. But in the meantime, I've got here, can we open more quizzes? I will in a second, Matt, thanks. I'm going a bit slow for this one just to make sure you get the idea, but pretty much tonight's all about this. So let me just do number 5 and then I might whiz through and set up a couple of more things for you. So what is the type of flooring system shown below? And so you've got to pretty much go back and look at the book and find the answer to that one. I'm going to let you actually all look through the rest of these ones. There's flooring systems that are shown, and you might have to go right up to the title, to the contents page here, and look at the different types of systems that they talk about. Slab on ground, suspended floors. There we're talking here, responsibility for design, types of suspended floors, the function, footing types. The question said, what is the type of flooring system shown below? And so we got a few different options. Somebody want to type in the page number? If somebody can type in the page number and the answer to this one, that'll be a good little check for you all. So we're talking here about types of floors. I'll just jump down here and look for types of footings, and I'm looking for a picture that probably looks the same as what's in that diagram there. Somebody said page 6. Okay, let's go back to page 6. Page 3, 4, 5. Here's 6 coming up. Okay, there's page 6 and page 7. And so what option do you guys think it is? A, B, C, or D? So what type of flooring system have we got here? It looks like we've got an infill slab on the top here. We've got control. This is actually an infilled slab type one. So it's strip and pad footings, pier and pile footings. You're thinking strip and pad footings with an infill slab. And let's see where that shows up. Someone else said pay. Here we go. Strip and pad footings. So that's figure 4.5. And that would be the strip and pad footings. We've got strip footings here. We've got a pad in the middle, possibly. Certainly we've just infilled. When might you use that type of footings? I've used one of those for renovating an old house because the timber floor was so rotted out it wasn't worth doing anything with it. We just tore it up, took the window out, put the concrete chute in after preparing it, and had a lovely concrete floor, no problem with rot or anything like that. So I'm going to let you all keep working on that one. And it's set 5:57 now. How about I check back with you in 3 minutes, and we'll see how you're going with it, and you can type in the chat pod if you're finished, and then we'll move on to some other ones, and we've got a few to get through tonight, so I'll try and speed it up a bit. But I've given you a demonstration of how you can find this information, and most of the rest of the activities tonight are going to be having a booklet open of some type, and then you're doing an activity so that you can get your job done. Tom's finished, Pete's finished. So 2 more minutes, and I'll see how many are finished, and we'll see whether we're ready for the next activity. Somebody's brought to my attention. This is great. Make a reminder for high with credit card to cancel. I got billed $111. Was that what you were saying? Yeah. That's a real good point, everybody. Martin's just popped up there. Be careful if you put in your credit card to access a trial for something, then unless you cancel it, it's probably going to bill you. You can contact them on their site and say that, sorry, you didn't actually want the full thing, and you might be able to show them how little you used it. And so just check that and make sure that you've got your credit card. Okay. Remember with credit cards that if there's a transaction that occurs that you didn't authorise, the bank normally is obligated to give you the money straight back, and then they'll pursue the person. So that's a reasonably safe way of purchasing things. And lots of people will probably have stories of that. But in this particular case, make sure with some of that software you downloaded that you've cancelled any subscriptions for it or things like that. So you just got to be careful of that type of thing. Somebody else used Project, was on the phone for 1.5 hours on hold. This Arvo going to try again tomorrow. That's right. That can be a little bit of an issue. So sometimes you just got to be careful when you download some of the software and things. How are we going with all of this? It is 6 o'clock. Have we got some more people that want a couple more minutes? If you need a couple more minutes, just type in the chat box. Ready to move on? Is everybody ready to move on? Anybody not ready to move on? Move on, move on, move on. Righto. I'm going to leave that. We're back onto our little lesson. So what I've just done for you there is given you one little green box, and the rest of this evening is going to be some activities where you can do that. I'll have a little bit of talking to do, but what I'll do is go through, and now that you know how to quickly access information, you can use the document, which is the book that's outlined there for you, and then you can use the quiz to quickly answer the questions, and you'll be able to get some green boxes real quick. Next thing I want you to do is we've got a little terminology activity here. This will actually give you a green box as well. I want you to quickly type into the chat box an example of any of those 6 different types of loads, because we're going to spend about 5-10 minutes now talking about loads and definitions and things. It's a tiny bit technical. If we get stuck, Kamal sitting next to me here is the engineer, will help us out, I'm sure. And but what I want you to do is to type into the chat box and add a discussion about what what some of those loads might be, and also the last one there, which is a span. So just type some things in there. Let's quickly have a look at that and see what your definition of a load could be. As you're doing that, I'm going to get ready to fire up the next site, which will give us some information on that. Actually, I won't put that up just yet because you'll get all your answers. So get yourself a brownie point, a green box, by typing into the chat box something that you understand by a live load, dead load, wind load, floor load width, roof load width, or span. Now, everybody should be right with number 3. So if you just can't think of anything, number 3 is real easy because that's just basically the wind load. And at the moment, as we learnt earlier, Wollongong is under a strong wind or medium wind warning for the coast. So that's actually going to put some wind loads on your buildings there. Is there anybody who's going to be game to be the first to type into the chat box here and tell us an example that you can think of a live load, a dead load, wind load, or what floor load width might mean, or roof load width, or the term span might mean. We don't have anybody who's... Type it in, Kamal. Type it in. Kamal's come up with one, live load. So anybody got anything there? I think they've all gone to sleep. Just think of what would be a live load, what would be a dead load. Dead load's really easy actually too, because it's just dead. It's not gonna, it's just whatever load it is you put on something, that's what it stays as. Live load is something that could move. You jump up and down, then that's going to be a live load because it's going to increase every time you land. Oh, did you put it? Can you put it in the chat box here, please, everybody? Oh, I can see people are putting stuff in the chat box on Teams, but can you put it onto the Moodle site, onto the discussion site? That's where you'll get your little green boxes. That's good, Kamal. Just put it onto the Moodle site. I should have made that a bit clearer. Oh, somebody said it's not working. Let's get that working so we can make sure that's all good. It should be working. There's no time period set on that, I think. Have we got, and here's a discussion, Matt, good job, Matt. So Matt said there with load, we've got some of the different loads. So people could be an example of live load. Constant load is a dead load. That might be things like, and wind is a wind load. A constant load is something like the actual flooring, the carpet, things like that. That's real good. Someone said kangaroo. That's a load. If you're going to have a kangaroo in your house, you've got to plan for it. Fair enough. Oh, dead load is a dead kangaroo. Yep, that's true. So even actually a dead kangaroo, if you're in a butcher's shop, I went to a place called Carachilna Hotel. It's way out in the middle of nowhere. You drive for hours and you come to this hotel, which used to be on the old Ghan railway line, and they sell kangaroo steak. And that they would put the kangaroo up on the table, but that would still be called a live load because they lift it up, put it on the table, cut it up. And the only way it would be a dead load is if they, I don't actually think you could have it as, but the dead load is things that are going to be more permanent structures that are fixed to the job, to the building. So we're getting quite a few different answers there. I'm not sure if, I think you can all see each other's. So just have a little look at what you're all putting in there. Roof load width or some of those terms we're going to talk about. I was interested to see whether anybody knew what those terms might mean before we talk about them tonight. They're technical definitions that we use for designing structures and things. Did anybody, rather than me check every single one, did anybody put in there a definition for floor load width or roof load width? Maybe just put in the chat box your name so I can highlight it. So Dan did. Dan, where are you on here? Dan did terminology. Let's have a quick look at that one. Okay, so Dan's put in there, so if you've put anything in here and you've got anything close to right, then you've had a little bit of a look at the standards before. So floor load width is the weight per span, that's good. Roof load width is still the weight per span. So we're looking at the span of that the weight is going to be carried across a member, and we're going to look at that tonight because we actually come up with a millimetre measurement for that when we work out different things. So we're going to have a look at that in a second. So that's real good. You can keep on getting brownie points by putting some chats in there, but I'm going to go back to and open up a real good site that Brett's been able to load up for you that we've been using for quite a few years, and I hope it never disappears, but it's possible that one day it will. And this has some good information here on structures and structural things. So you can see this has been hosted by the Melbourne Institute of Technology, and it's a project that was done probably 10, 15 years ago, and it's still really good content. So what we have on here is different loads and some activities and some things to teach you a fair bit about structures. Pretty much this site holds most of the content that we would use for this course. So you can see there we've got an example of loads, and when we look at primary loads, we've got things like dead loads, and if we look at a dead load, there's an example of a dead load. So that's the structure is the result of the weight of the permanent components such as beams, floors, slabs, columns and walls. And so dead load equals the volume of a member times the unit weight of the materials. So if we think in terms of that beam that's there, and you can see that I'm just moving my mouse around, if that beam has a certain weight and we know what it is, and if it has a certain weight per cubic metre, and we know how long it is and deep it is and how thick it is, how wide it is, then we're able to calculate what the weight of that beam is. And you can see that there's standard, there's measurements that have been done and that are made available to us in this table, which are standards right across the world for different products. So for example, reinforced concrete works on a standard of 24 kilonewtons per cubic metre. Okay, so if we've got a beam that's 10 metres long, 300 wide, 600, that's going to be 1.8 cubic metres. We times it by 24 kilonewtons, then we know that the weight of that is going to be 43.2 kilonewtons for that particular job. This is what engineers do. They work all this stuff out, and then they know that for the particular job, might be a beam on the front of Mr. and Mrs. Smith's house, and if that was the size of it, that'd be the weight that you have to allow for. So then if that beam is supported by a column on the right-hand side and a column on the left-hand side, we've got to allow half of that weight. We've got to have a column on the right and the left that can take half that weight, because half of it's on that side and half of it's on the other side. And this is how structures work. And we can look generally, and all products have pretty much got weights. I know that different softwoods have different weight, but as an average, you could be looking at 8 kilonewtons per cubic metre. Okay, and then we've got things like live loads, and here's an example of live loads. And people and furniture is a resultant live load. Okay, and if you look at the area of a floor, you have to work out the area. You come back down to your table, and we look at, for a normal house, we talk about 1.5 kilonewtons per square metre. So that's a standard live load that we use for a house. When we talk about offices and we talk about commercial type buildings, we might have to allow 3 kilonewtons per square metre. Okay, for a workshop we might be 5. You might have lathes and machines and things in there. Dance floors, we're up around 5. So you can see these buildings here have a different classification. Each one of those could have a classification in the National Construction Code, and all we have to do is work out what they are, and then we have to design our supports for those buildings that will be equal or more than what is the requirement is. So it's all about gathering the data from somewhere, putting it together and making sure that our building is built to the right strength. That gives you a little bit of an overview of how that works. Here's an example of wind loads, and it's pretty much what you all said. When the wind blows in one direction, it's going to create a force against the wall here, force against the roof, and it's going to create a suction, a negative pressure on the other side. An example of that was in the caravan coming back across the Murray Valley Highway the other day towards Yarrawonga. I missed a plastic bag, but the bull bar on the back of the caravan caught the plastic bag, and it just sat there blowing in the breeze without blowing out wildly, because there was a negative pressure on the back of the caravan at 95 kilometres an hour. And then as soon as I pulled up to put it in the bin, it fell on the ground and blew off in the paddock somewhere. So you get negative pressure behind things when you've got a positive pressure on one side, and that can create a suction. We have to allow for all that type of thing. We actually allow that. So wind loads are considered to be dynamic, and it varies greatly in intensity from time to time. If you look at this example, we have to plan enough bracing in that building to be able to resist the wind pressure that may come against that building, in this case from the left-hand side. And we have to plan that pressure coming from the left. And what we do is we make it so that if the wind changes and comes from the right, then we've got enough bracing to resist from that side as well. But then we also have to plan for the wind if in case it comes from on the ends of the building. And we're going to look at that a little bit later on. It's going to get a bit technical, but I think you'll be able to stay with us okay. So when we look at wind pressure, there's an example there, and you can actually have a look at those if you've got your flash player installed. I have to actually turn it on for this one, so you can actually, it's got some interactive things there for you. Actually, I had all this set up, but it's gone and disappeared. So I'm just going to highlight that there are some activities and some good interactive things for you on this site, which will go through and show you some different things. And I'll show you just where I found this from. Get rid of that one. So that was this site here, and I would recommend that you grab that site and do what I'm about to do with it. So I'm just going to click on the little favorite button up the top here, and I'm going to put it up the top because that's so that's come up to my favorites up here just there. And that's a real good one. If you've got a favorites button or a star or something on the left-hand side of your particular browser, I would recommend that you hang on to that site because that's a really good site for answering a lot of the questions and things that you're going to do throughout this whole unit. So hopefully that's making sense. Riley's put their area of floor supported by an individual bearer structure. Remember, that was relating back to floor load width. So we're going to come up to some of that now in a second. I'm going to actually turn on this video, and if we prime ourselves up and get ready for a video. If you're at home, just get yourself ready for this. In the other classrooms, just get this one ready. And this is going to be a build some video that'll run for a couple of minutes. And when you're finished, just type in the chat box, and this is going to explain a little bit about your floor load width definition. Yeah. I'm just going to pause my sound here. Okay, so just type into the chat pod when you're finished. Done. Lots of people done. We got most people done there. How are we going in Wollongong? Is my sound still coming through? Nope. Okay, thanks, Peter. I'm assuming that means my sound is coming through. All right, so that's pretty good. Now that just explains what you're going to need to know when you come up to some of the definitions and things a little bit later on. So there's a little bit of an introduction to that there. Now there's another video here that I'm just going to open up and show, and this one is going to be looked at a bit later, and that's roof load width. I'm not going to actually play that one, but it's going to go through roof load width, so that'll help you with that one. And then I want to show you a little bit from Australian Standard that you can access yourself. And of course, you know where you can get Australian Standard 1684 from, because that's going to be with all of your standards. And this little information here comes from, first of all, from Wikipedia, just to explain a bit more about span. And if you want to know any of the calculations or anything behind it, or plain person's language, not say plain right in the middle, but basically the term span is the distance between two intermediate supports of a structure, okay? And it can be a closed or solid. And I'm going to pretty much go and show you, I think I had down here somewhere, actually here it is here with Australian Standard 1684. And so I've already got this open for you, and I'm going to show you what, in the terminology, what where it talks about span, and I have highlighted this a little bit somewhere else. So span and spacing has a figure, and it talks about a couple of different definitions in 1684 that defines it. So it's the face-to-face distance between points capable of giving full support. We've got a couple of different types of span. We've got single span or continuous span. And in this particular case, you can see that the span is the distance between the supports, in this case for the joists there. Here's an example of the rafter span. That's even though it's on a slope, it's still considered the span. There's single span, and there's that's still classed as single span because there's a saw cut in the joist. So each one is classed as single, and we have to make that decision and choose that particular column, whether it be single or continuous, when we choose the size of the different members that we're going to look at. And this particular case down the bottom here is the continuous span, because when we have, if we have 1.5 kilonewtons of weight right across this floor, which is your normal house, then if you've got weight here, the weight on here is actually pushing down as well. And then it forms across here, the tension and the compression changes from the bottom to the top, and it gives a bit of strength to this side. So a piece of timber that's continuous span can span further than what a piece of single span material can, because it's just going to sag in the middle. It doesn't get any help from crossing over the support point there. So that's something to bear in mind when you come to, we've looked at some of the terminology. So that's all good. Now there's some information here on different types of floor systems, and what we've been talking to you mostly at this stage is based on Australian standards, and now and then we're just introducing a product which needs to be independently verified for its strength and its use and everything. And we want to drop a few of those in now and then, and that's what we're going to do now with this next video, which is going to introduce you to something that is quite unique. So this video goes for a couple of minutes. I'll just get it fired up here. And then you can see there 3.5 minutes. So just type in the chat box when you're finished. And I think you'll find this is something that you've probably never ever seen or heard of before. I'll just turn my microphone off and let That's the way. Just let us know when you're finished. Done. Looks like we're nearly done. So you can, that's an interesting exercise there, and it's fabulous, some of the different stuff that's available. What I'm going to do is actually open up for you the span tables for that prior one, which you can see here. And as you look at this, this is a manufacturer's booklet, 48-page booklet that they've made for this particular product. So this would be available on their website or when you buy their product, and it tells you how to design all the different parts of the product and how to put it all together. You're going to need that in a little while, because I'm going to open up an activity soon for you to be able to do with that. But because you're all pretty clever, I just want to finish some of the rest of some more content, and then I'll open up these quizzes for you to do, and you can work your way through those. So the next thing I want to show you is a steel floor frame systems from a Spantech site. Oops. So this is another product using Spantech, and there's going to be an activity after this which also has a quiz, which is based on the information that's in their site. I'm going to actually show you how you can find that, because this product is an example of where you can have another easy deck. So this is an easy steel type deck system where you can quickly build a deck, and we need to be able to specify and find information on these. So when you come to your quiz in a second, it's going to ask you to access the website and look for the specification guide for floor and rafter truss systems. Actually, in a little while, I'll put that up for you so that you can find exactly where it is. I think I've got it open here somewhere, but I'll put that up for you so that you can have a look at it. This particular this is another product that's available in Australia by a company, and they've done their own engineering. They've got their products and things available, and basically a floor system that you may choose to use for somebody's job. Okay, and there's videos and things on that. They're claiming the quickest and easiest flooring system you'll ever build. There's lots of different systems like that, and they're really worth looking at because they can make your job that much easier. So I'm going to put that question up. I'll put that activity up in a few minutes for you. I just want to show you some of these other things here first, because some of you are pretty fast-paced and you're ready to rip-roar ahead. So just going to show you now from Australian Standard 4671, Section 5, and a little bit about reinforcing steel. So we talked the other night about how steel has some nomenclature or some naming, and this has been set out for us in Australian Standard 4671. And when we go to specify steel, which you have to in a little while, we need to know how to classify it. And so it says here, reinforcing steel shall be classified by shape first, then the strength grade, and then the relative ductility, and then the size. If you're not sure what ductility means, then you need to go back to that site that I showed you earlier and said was a real good one for this one here about how to find loads and things, and you can find information about ductility on there. You'll be able to refer to it. So this particular, in this particular example, that's the way that steel is spoken about. And then we have the designation. Each of the reinforcing sheets described in one of the clauses there is by shape, strength, and that's an example of how the standard actually tells you how steel and things are ordered. And you've got an activity coming up soon, which is going to ask you to take off. I'll show you the activity and then the information, then I'll show you the activity. And this is going to ask you to take off this, some steel details off this couple of page plan that's on here. So this is some engineers details. And to be able to read that, which you guys and girls are pretty familiar with, you've got to be able to work out what some of the codes and what some of the different things mean. And when you look on there and you see, for example, SL82 mesh, well, when you get something that comes on site that you've got to know for sure that is SL82. It might say it on the docket, but you need to make sure that you've checked. Because if you put the wrong thing in there and get it already, and along comes the inspector and says, no, it's not the right one, it's SL72, then that's a bit of a problem. So you've got to understand what a 250 UB31 is. And it's written in code format. And that code is what I was saying to you a minute ago there, is classified in Section 5 of Australian Standard 4671. I've got that up there for you. And somebody said UB means universal beam behind me here. Very good. So here's Australian Standard 4671, and this Australian Standard is for steel reinforcing materials. And it's got the designation here. It goes through, and here's an example which I wanted to refer you to. So, for example, it says here, a deformed ribbed bar of a grade 500 megapascal normal ductility steel with a nominal 16 millimetre diameter would be a D500N16. So you see this product arrive on site that says D500N16. Well, how do you know what that means? You go back up here to the standard, and you can see how it's designated. Reinforcing steel has the shape, the strength, the ductility, and the size. Okay, so we've got the bar. In fact, in this particular case, it's got the shape first. That's the reinforcing steel sheets. So it's got shape, strength, ductility, and size. And there's shape, which is the D, strength, which is the 500, and the N is the normal ductility. So that's the third part of the code, the N, and then the 16 is the millimeters diameter. You can see how that code relates back from the designators there. And so that's an example of how you can read that information, and you may need that as you go through and do this next little activity, which I'll open up in a second. So the very last thing that I'm going to talk about before I quickly put these activities on is some waffle pods. And so that's all pretty good there. I'm just going to open up this waffle pod one. Most of you have had something to do with waffle pods. Thanks, Riley. You said Spantax systems are really easy to use. So if any of you have used these sorts of things, definitely share the information around with each other. In this particular activity, to get the next green box, says explain in your own words how waffle pods are preferred in comparison to a standard raft slab. Now, what you might be explaining is what you've experienced yourself. So pop that in the chat box on the Moodle site. Don't pop it in the chat box over on the Teams site. And while you're putting in your chat box in your information there, I'm just going to open up 2870, and we'll have a quick look at. Here we go. We'll have a quick look at a waffle pod. So just go ahead and type in your answer as to why somebody might think that waffle pod's good. If you think it's no good, then type that in there as well. Waffle rafts. There we go on page 33. That's probably page 33. Nope. So go ahead and type that in. Here's a definition of a waffle raft: a stiffened raft with closely spaced ribs constructed on the ground and with slab panels suspended between ribs. And here's an information 3.4 in Australian Standard 2870 on waffle rafts. They shall be specified in accordance with figure 3.4. I think that's 3.4 there. But this is basically, it forms a void and gives you deep beams in between the voids. Australian Standards isn't going to tell you how good waffle rafts are or the negatives or anything like that. It's just a technical document. If you want to find out the positives and the negatives of waffle rafts, you've got to look on the chat box, which I'm going to check and see if somebody's put information in there. Oh, yes, we've got a few coming up here. Let's see what Lachlan says. Thanks, Lachlan. They're easier to install as they're placed directly on a flat level ground. Very good. No need for trenches. That's an example of them. You actually form the trenches. Cheap, easy, and crap. There's lots of people who don't like them. Thanks, Tim. And there's lots of examples where the engineer specifies them, but they still crack. One of the most important things with your slabs or any concrete work is that you cure it. And a lot of people don't cure it properly. So pretty much when you do the concrete, allow in your quote time to go back for the next week after it and keep the sprinkler going on it to keep it moist, so that you don't get cracks and things developing, or whatever method of curing you've chosen. Cleaner footings, no collapse of footings and size blowing out. That's right, because the whole thing's built like the diagram shows us here. Here it is. This is how they're built. It's basically built on the flat ground level. Can be built on a flat ground level. So you're up off the ground straight away. And what's Jake put in here? Thanks, Jake. Cheaper labour and costs. Very good. So as with anything, you might think it's cheaper or dearer, but it depends very much on every individual example. We have some people in Wagga and all they use is waffle pods. We have some people in Wagga and they'll never use waffle pods. So, and they're real used to using waffle pods and set up for it, so they can do it real cheap and quickly. Other people are used to using something else, and so it can be a bit of an individual type thing. You're going to develop your own methods of doing things, but you get the concept here from what everybody's saying, and you can go through and have a look at those examples yourselves as well, and that's waffle pods. Just going to quickly, just to finish talking a little bit about waffle pods, I'm going to quickly open up a PowerPoint that I'm just going to skim through on it, because this will, if you've never seen these before, this will give you a couple of pictures of some waffle pods as they are built, and I think the whole thing's coming up on there. Let's just make sure everything's coming up good. So there's an example of a picture, and in this case, the guys of Brett or Glenn have put up a picture of a waffle pod site. Now, I was down at a site near here, I forget where it was, it might have even been in Wagga, at a suburb being built recently, and the wind was howling through, and people are running around trying to stop these foam, real light foam things from blowing off into the breeze, because that can be a real problem. So you've got to really watch that. And in this case, they've got them all tied down pretty well, so that's good. You can see pretty much what you do is you're going to level your site, and then you're going to form up the edges of your site. You're going to put your waffles in there, and they're going to be spaced a certain distance apart. And then there's going to be steel eventually that's put on them. At this particular stage, you've got to get those waffles in there and hurled down real quick so that they don't blow away overnight, because once they move, then it's mucked up your whole job. Basically, what we're doing here is putting any pier holes that might be needed in, and then we can put attachments in that holds the waffles a certain distance apart. And you can see from this example that there's a groove in the middle of that plastic divider that will allow a rebar to be able to put down and through in under there. So lots of people, thanks for your comments on there, everybody, that's good. So when you look at this, you can still have differences in your slab heights. You can pretty much cut that with a saw because it's only just foam, and it's just going to form a void and save filling up the whole site with concrete, and that's going to form nice beams and things in there. You can see here's an example of some bars that are deformed that are going to have to be placed somewhere into the site. When you get all the steel on site, it might look something like that. And you've got to go through and check and make sure that what's been delivered matches what the engineers asked for, so that when the inspector comes, you're going to be able to get a pass. You can see where those bars have been placed, those Z bars, in this particular case, tying in the top reinforcing with the trench mesh. And I'm assuming there'll be some edge form that gets put onto this slab, which I think we can just see it starting to develop on the bottom of that slide. There's some edge form that's been put in. A lot of people who do this all the time, they have edge form that's made out of C-section steel, and they'll have a hole in the steel where they can just clamp it up and down at the right height and drive pegs in and that type of thing. They become quite quick and efficient at doing it after a while. So inside that slab, you wouldn't know it, but it's got a lot of foam, and that was able to be built on a relatively level site or level parts of a site, and that's an example of how that can work. So I think you all have lots and lots of information now about how different products work. There was one example of a video tonight that I think I may have missed that showed you a real unique type of footing system, and I'm not sure if I can actually find it now. Maybe we can pop that up there a bit later, but what I'm going to do now is open up the quizzes, and you're all good to go for it and fill out the quizzes, and you can see what's happening is that there's information and then there's a quiz, and then there's information and there's a quiz. So I recommend that you open up both the information and the quiz, and then just go through and fill them in based on searching your way through the information. So at this stage, everything's been opened up, and just want to open it up for any questions. As Brett said there, you need to complete all those assessments, because they're going to introduce you to some of the information that we may have not have bored you with by talking about. It's going to teach you how to search through the codes and things. So I think we can probably stop the recording, and